when working with word problems that involve right triangles, it is important to know what some of the terminology means. Some of the stuff they could be saying are line of sight, or angle of elevation, angle of depression, or angle of inclination. Not always are these words used or these phrases used, but if they are, you should know what they mean. Makes your life a little bit easier when trying to solve them. So let's look at the question we have here. From a point on the ground 500 feet from the base of a building, an observer finds that the angle of elevation to the top of a building is 24 degrees, and that the angle of elevation to the top of a flagpole atop the building is 27 degrees. Find the height of the building and the length of the flagpole. So what I'm going to do is I'm going to draw it out and make it a little bit easier for me to see. So got some building here. And I have a flagpole on top of it. So flagpole, flag. And someone's standing down here. And from where they're looking up to the top of the building, we know that this is 24 degrees. But from the same position, looking to the top of the flagpole, the entire angle here is 27 degrees. So this one right here. And we know that from where you're standing here to the building, it is 500 feet. So how can we find the height of the building and the length of the flagpole? Well, I need to find the height of the building, which is this part here. So I'm going to say that this is h. And I'm given this is the angle here. I have a height that I'm trying to solve for, and I know this length here. So I have an opposite and an adjacent in comparison to this right triangle. So dealing with opposite and adjacent makes me think of tangent right away. So that's what I'm going to do. I'm going to say tangent of 24 is equal to h over, clean that h up a little bit more, h over 500. And that is the 24 degrees here to the top of the building. And then I can just solve for h here to find the height of the building. So multiply the 500 over. I'm going to get 500 tangent of 24 equals h. Nice and simple. Put that in a calculator, making sure it's in degree mode. And I'm going to get h is to one decimal place, 222.6 feet for h. So this is the height of the building. So height of the building. But I still need to find the length of the flagpole. So the flagpole is, however tall it is, sitting on top of the building itself. So what I can say is that I'm going to call this height here all the way down to the ground capital H, because it's a bigger height. And since I know what the angle is here, 27 to the flagpole, I know my opposite is a capital H, and I know the distance is still 500, I can do tangent again. So tangent of 27 degrees is equal to capital H over 500. And now I solve for capital H to get the height of the building and the flagpole. So multiply the 500 over. Tangent of 27 equals capital H. So I have 500 times tangent 27. And again, I plug that into my calculator, and I'm going to get to one decimal place, 254.8 feet for capital H. Now this is the height of the building and the flagpole combined. So what I'm going to do is I'm going to take the height of the building that I know is 222.6, subtract it from the combination of the two, and I'm going to end up with the height of the flagpole itself. So 254.8 minus 222.6 is going to give me 32.2 feet. And so this is the height of the flagpole.